right, this is the fourth and final part of the midterm practice test review. So we're looking at number 25. It says write the given interval as an inequality involving x and then use the real number line to illustrate that. So this has two brackets, which means we're including the values, and we're shading in between when we see interval notation that goes from one endpoint to another. So writing that as an inequality, this would say that 4 is the smallest that we ever get. Sorry, my pen just doesn't want to write, and then less than or equal to, since we have a bracket, x, which is floating in between 4 and 9, all solutions possibly in between, and less than or equal to 9. And again, for some reason, when I printed this from my math lab, it lost half of the graphs. B is the correct one because it has a 4 to 9 shading, which I'll show you what that looks like. It has 4 with a bracket and 9 with a bracket, and they shade everything in between. So even though you can't see it, that is the correct shading and picture for that specific inequality. Okay, so number 26 is to find the real solutions of the equation. So we need to isolate this absolute value. That's our first step. So 2 minus 4t equals 23 minus 5, so that's going to be 18. Now, remember, there's two possible ways this could work. Either the inside was a positive 18 before they took the absolute value, and that would give me 18, or the inside was a negative 18 before they took the absolute value, which also has an absolute value of 18. So you have to set up both of those possible insides for your absolute value. So this is one case, or here's the other case. We would subtract 2, so this is negative 4t equals negative 20. That would be t equals 5. This one we would subtract 2 and get a 16 on the other side. And divide, and we get negative 4. So the solution set is negative 4, comma 5. Okay. Number 27 says start with the graph of the basic function and graph the following transformations or techniques to shifting, compressing, stretches, and or reflecting. Find the domain and range of your function. So this is x cubed's parent function is the shape. So I'm going to graph that guy right here first. So 0, 0, and I'm getting x cubed, the points, by just plugging in numbers. So 1 cubed is 1. But negative 1 cubed is negative 1. It's not a straight line though. If you plug in a half or a negative a half, you'll see that this is kind of curved. So if you aren't very familiar with x cubed, you might want to obviously graph more points than those 3. But I just need 3 points to key in my key of shifting that I'm going to do. So when you see a plus or minus a number inside of the function, so inside of the cubing part, that means we're going to have a horizontal shift. And a horizontal shift is always the opposite of what you see. So since this is minus 4, we need it to make this 0 again. So we're going to have to go right 4. Okay. If you have a number added after the function, that's going to be a vertical shift, and you do exactly what you see. So we're going to do positive means up to. If it had been negative, we would have gone down to. And then we also have this negative out front. When you have a negative in front of a function, it reflects across the x-axis. Now, when you go to move your 3 key points, you have to do this as kind of like order of operations. So whatever's inside the parentheses and closest to x gets done first. Then any reflections, compressing, or stretching out front is multiplication, so that would be done second, and vertical shifts would be done last. So this is moving right 4 first. So I'm going to kind of do a rough sketch. So that I'm going to do each of these, and then we'll graph our final one on the grid. So x minus 4 cubed is just to take each of those points and move them right 4. So 0, 0 is at 4, 0. 1, 1 would have been now at 5, 1. And negative 1, 1 would be at 3, negative 1. So notice not final answer yet, just shifted right 4. Then I need to reflect across the x-axis, which puts the negative in front of my graph. Sorry, this pen is really not wanting to write right now. And then that would make this whole graph just flip all of the x all of your y value points change sign. So if you're at a negative, you go to a positive. If you're at 0, you stay where you're at. If you're positive, you go negative. So this makes this just flip upside down across the x-axis. So 4, 0 is still the same point. 3, negative 1 would now be 3, positive 1. 5, negative 1 would now be, 5, positive 1 will now be 5, negative 1. So now the graph looks like this. And then lastly, we want to go up 2. So I can do this on my final graph. So I'm at 4, 0, and I want to go up 2. I was at 3, positive 1. I also want to go up 2. I was at 5, negative 1, and I'm going to go up 1, 2. And then remembering to keep my shape, my x cubed shape. So it was down this way and up this way. And again, yours will probably look better than mine. So the domain is still all real numbers because this is a polynomial. Polynomials should have all real numbers as their domain. And this also has no range restrictions. This goes up and down forever. So it's also negative infinity to infinity. Now, a parent function that might have domain restrictions, of course, would be like parabolas because they go in the same direction. So there's always a lowest or highest point. Square roots of x have domain and range restrictions. But the x cubed, cubed root of x, those both are all real numbers. And absolute value has a domain restriction, or actually it's a range restriction. Its domain is all real numbers. So depending on which of the 5 parent functions or basic functions you get, there may be changes to that domain and range. Okay, so number 28 just says, determine whether this equation defines y as a function of x. If you cannot solve for y without having multiple equations, which we cannot here, because to solve for y, you would have to throw on a plus or minus square root, which means this has 2 separate versions of this equation. So it's not able to be solved for y individually. So that is not a function. Again, essentially, if y is squared, it's going to be, you're going to have problems. And that's because you usually get something that looks like this, like a parabola on its side. So that is not a function of x. Okay, finding the real solutions of the equation. Now this is another absolute value, but it's equal to a negative. This one is not, you don't need to do anything. If you are doing absolute value should always come out as a positive distance. So a positive cannot equal a negative. So a lot of times people will solve this equation and then get answers, but none of them plug back in if you actually check. So if your absolute value is isolated and it equals a negative number, it is not going to be solvable. Number 30, it says find the real solutions of the equation. So this looks quadratic. It does not factor. So we'll probably be using the quadratic formula like it says in the directions. So remember, this is a is 1, b is negative 6. You do have to worry about the sign, and c is negative 2. Now you can only label a, b, and c if you have it equal to 0. So a is the x squared part, constant or coefficient, b is the coefficient on the x, and c is the constant. So remember, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative b means opposite of your b. So x equals 6 because it was already negative. Get my pen just a second to catch up. Plus or minus square root original b, which would be negative 6 squared, but we are squaring the negative, minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a. So this is 36, and this is negative times negative, so that's going to be plus 8. So it looks like we're getting the square root of 44. I'm going to write that on my next line. So 6 plus or minus square root of 44 all over 2, and we need to reduce this. So we would take out a square root of 4. So that square root of 4 would be a 2. We'd still have 11 inside because 4 times 11 is 44. And then all of these numbers on the outside are divisible by 2. So this actually ends up being, and I'm running into the other problem. So this is 3 plus or minus 1 on the square root of 11 all over 1. So you don't need the over 1. And you would write this as two separate answers because it does say separate them. So typically we write the minus case first, comma, the positive case, but you don't have to always write it that way. My math lab should know if it doesn't specify which one, so either way should be acceptable. Okay, almost finished. So number 31 is write this in standard a plus bi form, but you have an I in your denominator, which is just like having a radical down there because that's what I stands for, is the square root of -1. So to get rid of that, you use the conjugate. Now the conjugate is the same exact binomial, but you change the sign in the middle. That will make it FOIL out nicely so that there's no i's left. Whatever you do to the bottom of a fraction or denominator, you have to do to the numerator. So 7 plus 4i gets distributed in both places. On top, that would be 21 plus 12i. On the bottom, you get 49 plus 28i minus 28i. And then this is the one part you have to be very careful about. If I can get my pen to catch up. There we go. It's -4 times 4, so that's -16, but then there's an I squared. I squared is -1, so that actually makes that term cancel out its I completely, and it becomes plus 16. So it changes the sign of the number, and there's no longer an I. The middle terms also cancel. So this is 21 plus 12i all over 49 plus 16, which is 65, I believe. Yes. And then we need to break it into the a plus bi format. So this is a step that'll get you if you don't do this. You have to do the 21 over 65 as your first part. That's your real number part. And then plus 12 over 65i. And again, you would want to check and see if each of those is reducible or not. Just using your, calculator, you can check that, but they're not. Okay, number 32 says use the graph of the function given below to answer the following questions. List the x values at which f has a local maximum. Okay, so a place where you have a hilltop. So the x values that occurs for, you're going to have to count. This is -11, -12. So at -12, we have a highest point attached to that. And at 1, 2, 3, 4, it looks like, yep. So those are the places where we have a local maximum. Those are the x values attached to those hilltops. What are these local maximums? When they ask that, they're asking what is the height, and that is 15 or 16, is it? Oh, it's 16, yeah, sorry, it's hard to see here. So the local maximum height is 16. Is there anything else on this one? I don't think so. They didn't ask us about the minimums, but if they did, we would have counted where's the minimum occurring, and then -16 would have been the actual minimum value. All right, last question. So this one has half the graphs missing again, so we're just going to have to show the picture ourselves, but we're going to try to solve it first. Now this is where people can get in trouble because absolute values shouldn't be less than negative numbers. That means your distance is less than a negative, but you have to isolate the absolute value first to determine that. So this -11 needs to be added over, and that actually fixes the problem there. So don't always just say no solution just because you see a negative on the right side. If it's a greater than, it's actually all solutions. So, but you have to isolate before determining that. So that's going to make this a 5 when we add the 11 over. So this is the less than case. When you're doing a less than case, you put the inside part between two less than symbols. So 1 minus 6x. And you say that my bubble is between -5 to 5. So then I need to solve this by moving the 1 away from the center, and you have to do that to all the sides. So that'd be -6 less than -6x less than 4, because we subtracted 1 from the left side, the middle, and the right side. You could set this up as two separate inequalities and solve them, but that actually complicates the interpretation at the end when you do your final answer. And then we want to divide everything by -6. Now, when you divide by a negative, you must be careful because that flips the inequalities in the other direction. So this is now greater than, that's an x. This is a 1. This is a -2/3. This is still from one endpoint to another. It's just they've got it now in backwards order, because when you get greater thans, you're going in descending order. We want to be in ascending order. So this is -2/3 to 1. We are shading everything between those two numbers. So least to greatest. And the graph that had that correctly graphed was, I believe, D. It had everything shaded in between the two numbers with parentheses on both. So they had, you know, where here's -1. I'm just going to do a rough graph. Here's 1. Here's 0. So they had -2/3 to 1 graphed. And the brackets versus parentheses has to do with whether or not the equal to symbol was in the original problem. Okay, so that's a lot of information. I tried to go through the whole entire test with as much detail as possible, tried to give you some tips and tricks on how to use, you know, the multiple choice to your advantage. I have my regular office hours this whole week, if those are in the syllabus. If any of those match up with any of your times that you are studying, you know, and you're home, you can always either call me or come by and see me. If that doesn't work, but you still need some extra help and you can't find a place like the LRC or anywhere to go, please just reach out to me. Maybe we could do a Zoom meeting real quick one night. You know, I'll have to plan it around my schedule and your schedule. But just make sure you reach out if you're struggling. I want you to have the best chance of getting the best grade on your midterm exam. I hope this was helpful, and I look forward to hearing from you guys if you have questions. Have a good evening.